Let's solve reversing a linked list. But first, let's take a look at a single node and how we would draw that out. So here we have a node, and the node has an arrow which is going to resemble the .next portion of the node. So we have our node current, and it's pointing to another node. Current.next is the arrow because it's showing it is a pointer to the next node. It's not actually the next node. So what we want in this operation of reversing a linked list is to take the current.next and make it point the other way. By making point the other way, we literally mean reverse what it's equal to. So instead of pointing to the other node, it's going to be pointing to whatever was on the left. And the same for all other nodes. So this way, we're physically representing what we're trying to do in the code. And this is going to help us understand what the code needs to do. So again, going back to the simple case, even with one single node, you just take current.next and you point it to whatever was on the left. Now, whatever was on the left is usually going to be some variable, but this gives us a hint as to the pseudocode is what we need to write. Current.next equals whatever was on my left. Now, if we can think about it, we can just shift current to the next node and do the same thing. We can imagine now that the red node will be our current and that the red node's pointer will be current.next, and we will do the same thing of shifting it to the other side. So again, we repeat the operation. Current.next is now equal whatever was on my left. What did we do? We moved the variable current to the red node, and we said current.next is equal to the previous value. In this case, we're going to use previous to denote whatever was on our left. So now we can get started with the code. Again, we're trying to reverse the list. We're going to take the example of 1, 2, 3, null. We're going to have previous as P, C as current, and N as next. So if we remember from our graph, if we remember the whole operation we needed to do is set current.next to point to previous. And then what we do is we shift the values previous, current, and next to the next node. And then we apply the same logic that we did before. So first, we reverse it, and second, we shift the assignments, the variable assignments, so that we can apply the same logic again. So we can set previous to null because in the beginning there's nothing on our left. Current is our head, and next will be current.next. We want to make sure that current is something and it's not null, and we're going to iterate. Well, we have a value in current. Again, current.next will be equal to the previous value. Now we shift, which is by doing previous equals to current, current equals to next, and next equals to n.next. We're shifting value by value, starting from the leftmost to the rightmost. Why don't we do it the other way? Is because we would lose the pointer, we'll lose the next pointer, and current wouldn't be able to assign it. This way it's cleaner, and I like to think of it, if it were a worm, how would a worm move? A worm moves its tail first, and that's how we progress forward so that its body can stay nice and compact. At the end, we return previous. Here there are some slight errors where we set it to null instead of none. Again, why do we return previous? It's because we're doing it until current is nothing. So the last variable, which is going to be the last variable of the linked list, will be previous. Thank you again for watching. If you want more videos like this, please like, subscribe, or comment. If you have any questions, feel free to ask. We're always here for you. Have a great day.